Hello everyone. Let us explore a very interesting geometric fact. If a triangle and a parallelogram share the same base, here both of them are sharing the same base and lie between the same parallels. So the triangle and the parallelogram lie between these two parallel lines. Then the area of the triangle would always be half of the area of the parallelogram. Now let us deep dive into it and see why this is true. So we have a triangle ABC and a parallelogram ABEF. So what is given to us is a triangle ABC and a parallelogram ABEF lying on the base AB and between two parallel lines AB and EF. Now what we need to prove is that area of triangle ABC is half of area of parallelogram ABEF. Let us start with the construction. Through this point, this vertex B, we are going to draw BH, which is parallel to AC. And it meets this FE produced at H. Now, if you notice over here, AB was already parallel to this line, CE, and now extended CH. And BH is parallel to AC. We have constructed it that way. So, we can say that ABHC is a parallelogram. This one, right? Let's make it a little bit transparent. So this is a parallelogram, and over here, this BC is its diagonal. If we recall, diagonal of a parallelogram divides it into two congruent triangles. So BC here divides it into two congruent triangles. And if the triangles are congruent, that means their areas are equal. So area of triangle ABC is equal to area of triangle BCH. Congruent figures have equal areas. Let's write it down over here. Now, if you just look at this parallelogram ABHC, it is made up of two triangles. So its area would be sum of areas of two triangles. But we know that these two triangles have equal areas. So we can say that area of ABHC is twice into area of triangle ABC. That gives us area of ABC is half of this parallelogram ABHC. Let us call this equation 1. But a parallelogram ABHC and parallelogram ABEF. ABHC, that is this one, and ABEF, that is this one. They are on the same base AB and between same parallels AB and FH. So we know that this is a theorem that if the parallelograms are on same base and between same parallels, their areas are equal. So area of ABHC is equal to area of ABEF. Now let us substitute this in equation 1, which will give us area of triangle ABC is equal to half of area of parallelogram ABEF. And that is what we wanted to prove.